It's roughly 400,000 years ago. You're a human, barely recognizable as one, but still. You wake up, look around at the landscape, and at absolutely no point do you think you know what would really complete this morning: heat. And yet here we are, 8 billion people every single day setting things on fire before putting them in their mouths. We have entire television channels dedicated to it. We give people trophies for doing it well. We built a global industry around the concept of please cook this before you eat it. But here's the thing nobody asks. Why? Why are we the only species on Earth that refuses to eat food the way we found it? Because no other animal does this. Not one. And the reason we started, the actual reason, didn't have anything to do with taste. It had to do with something happening inside your skull, something that changed what humans were permanently on a biological level. And it started with an accident nobody planned and nobody noticed until it was already too late to go back. Let's start with the obvious question that somehow never gets asked. Why do we even need to cook? Every other animal on Earth eats raw food. Every single one. Lions eat raw meat. Gorillas eat raw plants. Dolphins eat raw fish. The entire animal kingdom, every species that has ever existed across 4 billion years of life on this planet, has consumed its food in the state it found it. No preparation, no seasoning, no 15-minute YouTube tutorials on knife technique. And they're fine. Gorillas are enormously strong. Lions are apex predators. Dolphins are so cognitively sophisticated they have started to make researchers deeply uncomfortable. None of them cook. None of them seem to miss it. So if raw food works for literally every other living thing, why did we decide it wasn't good enough? The conventional answer is cooking makes food safer. Heat kills bacteria, it kills parasites, it reduces the risk of food poisoning, and this is true. Completely, genuinely true. Cooking absolutely does make food safer. But here's the problem with that answer. It assumes our ancestors understood germ theory. It assumes they connected eating raw meat on Tuesday to feeling terrible on Thursday. It assumes they had a reason to cook before they started cooking. They didn't. The real answer runs much deeper than food safety. And it starts with a word you probably haven't thought about since high school biology: calories. Not in the modern diet culture sense of calories as something to fear and count and feel guilty about at 11 p.m. while standing in front of the refrigerator. Calories in the original biological sense. Energy. The raw fuel your body runs on. The thing that keeps your heart beating, your lungs expanding, your brain doing whatever it's doing right now. Here's something genuinely remarkable about the human brain. It is extraordinarily expensive to run. Your brain accounts for roughly 2% of your body weight. It consumes roughly 20% of your total energy. That ratio is almost unheard of in the animal kingdom. You are walking around with the most metabolically demanding organ in the history of life on Earth sitting inside your skull, and it requires constant, reliable, enormous amounts of fuel just to keep the lights on. Now think about what raw food can actually deliver. When you eat a raw carrot, your digestive system can extract only a fraction of the available calories. The cell walls of plants are made of cellulose, a tough, fibrous material that the human digestive system cannot fully break down. A lot of what you swallow passes straight through. The energy is locked inside the cells. You can't get to it. Same with raw meat. The protein structures are tightly coiled. Breaking them down requires enormous digestive effort. Your gut has to work extraordinarily hard to extract the nutrition, burning significant energy in the process just to access the calories inside. Raw food is, from a caloric efficiency standpoint, a genuinely terrible deal. And here is where fire changed everything. Heat does something to food that digestion cannot. It breaks down cell walls before the food even enters your body. It unravels protein structures. It gelatinizes starches. It essentially pre-digests your meal for you outside your body before you take a single bite. Cooked food delivers dramatically more bioavailable energy than the same food eaten raw. In one experiment, researchers fed pythons the same amount of meat, some raw, some cooked, and measured the energy cost of digestion. The pythons digesting cooked meat spent significantly less energy processing it. Now, pythons are not humans, but the underlying chemistry is the same. Heat changes food at a molecular level in ways that make it fundamentally easier for any digestive system to process. For humans, the difference is even more dramatic. A cooked potato delivers nearly double the usable calories of a raw potato of identical size. A cooked egg provides around 90% of its protein in a form your body can actually absorb. The same egg eaten raw delivers roughly 50%. That gap between what raw food promises and what it actually delivers is the gap that cooking filled. And filling that gap changed everything that came after. Richard Wrangham, a primatologist at Harvard University, has spent decades arguing for what he calls the cooking hypothesis. The core claim is this: cooking didn't just change what humans ate, it freed up an enormous amount of energy that had previously been consumed by digestion. And that energy went somewhere. It went to the brain. Think about what that means. Before cooking, a significant portion of your ancestors' caloric intake was being spent just on the digestive process itself. Long intestines, large digestive organs, enormous chewing muscles, all of it running at full capacity just to extract enough nutrition from raw food to survive. It was expensive. It was inefficient, and it put a hard ceiling on how much energy could be redirected toward the brain. Cooking smashed that ceiling. With cooked food delivering more calories more efficiently, the digestive system could afford to shrink. Smaller intestines, smaller stomach, smaller jaw muscles, smaller teeth, and with the energy savings from a less expensive gut, the brain could afford to grow, and grow it did. Here's the number that should stop you cold. The human brain is roughly 3 times larger than you would predict for a primate of our body size. 3 times. That gap between what evolution says we should have and what we actually have is one of the most discussed puzzles in all of paleoanthropology. And Wrangham's argument is that cooking is the answer. Not just part of the answer, the answer. The timeline fits. Evidence of controlled fire use by human ancestors dates back at least 1 million years from a site called Wonderwerk Cave in South Africa. The same cave that came up in the smoking video, because apparently one cave in South Africa is doing a lot of heavy lifting in human evolutionary history, and the fossil record shows a clear pattern over that same period. Gut size decreasing, jaw size decreasing, brain size increasing, all 3 trends moving in the same direction over the same time frame. That is not a coincidence. Compare us to our closest living relatives, and the difference becomes almost absurd. A chimpanzee has a gut that accounts for roughly twice the body mass proportion of a human gut. Their intestines are longer, their stomachs larger, their digestive systems built for the hard labor of processing raw plant matter. They have massive jaw muscles that attach to a pronounced ridge running along the top of the skull, a feature called a sagittal crest, specifically to generate the chewing force raw food requires. Humans have none of that. Our jaws are weak by primate standards. Our teeth are small. Our gut is compact. We are, digestively speaking, the least impressive great ape on the planet. And we have the largest brain. Those 2 facts are not unrelated. We traded gut for brain. We traded chewing power for thinking power. And fire is what made the trade possible. Now here's where we have to be careful, because correlation isn't causation, and the archaeological record is frustratingly incomplete. Not everyone agrees that cooking alone explains the brain expansion. Some researchers point to meat eating generally, cooked or raw, as the primary driver. Others emphasize social complexity, language development, or tool use as equally important factors. But here's what makes the cooking hypothesis hard to dismiss. It's not just about calories in the abstract. It's about time. Raw food takes an enormous amount of time to process. Chimpanzees spend approximately 6 hours every day chewing. 6 hours. Every day. Just chewing, not hunting, not socializing, not solving problems, not learning anything new. Chewing. Because raw plant matter requires that much mechanical processing before a primate gut can do anything useful with it. If you watch chimpanzees in the wild, a significant portion of their waking life is simply jaw movement. Constant, relentless, exhausting jaw movement. Humans, eating cooked food, spend roughly 1 hour per day chewing. That is 5 hours per day freed up. 5 hours that our ancestors could spend doing literally anything else. Socializing. Problem solving. passing knowledge to their children, building tools, looking at the sky and wondering what was out there, making art, making plans, making mistakes and learning from them. Cooking didn't just feed the brain, it gave the brain time to be a brain. And this is where the story stops being purely biological and starts becoming something larger. Something that touches everything about what humans are and why we are so different from everything else that has ever lived on this planet. Let's talk about fire itself for a moment, because before cooking, fire was already changing human behavior in ways that are easy to underestimate. Fire extends the day. In a world without artificial light, darkness means vulnerability. Predators that hunt at night, cold that kills, disorientation that gets people killed. A fire at the center of a camp pushes back that darkness. It creates a protected social space that didn't exist before, a place where a group can gather after the dangerous hours have begun, safe enough to relax, close enough to talk. The campfire, researchers have argued, was the original social technology. Anthropologist Polly Wisner studied the Ju-Hoanzi people of the Kalahari, one of the last remaining hunter-gatherer societies on Earth, and documented a striking difference in what people talk about during the day versus at night. Daytime conversation was mostly practical. Tasks, resources, logistics, conflict resolution, the immediate demands of survival. But nighttime conversation around the fire was different. Stories, histories, myths, the transmission of cultural knowledge across generations. Wiesner called firelight the original medium for storytelling. The campfire didn't just cook food, it created the conditions for culture, for narrative, for the kind of shared imaginative life that separates humans from every other species more than any physical trait. Before the fire, there was no good place or time to tell stories. After the fire, every night became a classroom, a theater, and a community meeting all at once. And cooking happened inside that social space. It was communal from the very beginning. You don't cook alone in a world where gathering fuel and tending fire and preparing food are all survival critical tasks. You do it together. And doing it together changes things. It creates dependency. It creates cooperation. It creates the need to share. There's evidence that food sharing, distributing cooked food among group members rather than each individual foraging and eating alone, dramatically changed the social structure of early human groups. It created reciprocal obligations. You cook, I hunt, I bring the roots, you tend the fire, proto-economics. The earliest version of the social contract, written not in ink but in the distribution of a shared meal. All of it orbiting the flame. But here's the piece of this story that almost nobody talks about, and it might be the strangest angle of all. Cooking changed not just what we ate, but what our bodies expected to eat. Human digestive anatomy has been shaped by millions of years of cooking. Our stomachs are small relative to our body size compared to other primates. Our intestines are shorter, our teeth are smaller, our jaw muscles are dramatically weaker. These are not neutral features. They are adaptations. Physical changes that make us better at processing cooked food and fundamentally worse at processing raw food. There have been documented studies of people who attempt to subsist entirely on raw food diets long-term, and the results are striking. A significant proportion of women on strict raw food diets stop menstruating, not because of ideology, not because of any philosophical commitment to the lifestyle, but because their bodies simply cannot extract enough calories from raw food alone to maintain reproductive function. The body reads the caloric shortfall as a famine signal and shuts down non-essential systems. Reproduction is the first to go. Let that sit for a second. The human body has been so thoroughly reconfigured around cooked food that eating the way every other animal on Earth eats, the way our own ancestors ate before fire, is now calorically insufficient for basic human biological function. We didn't just adopt cooking as a habit. Cooking adopted us. It rewrote our bodies around itself and then made itself indispensable. You cannot, strictly speaking, fully thrive as a human on raw food alone. Not long term. Not in the way evolution designed you to thrive. The fire is built into the blueprint now. It has been for so long that we've completely forgotten it's there. Think about the implications of that. Every cuisine in human history, every recipe ever written, every grandmother who ever passed down how to make something exactly right, every meal shared at a table, around a fire, at a celebration, at a funeral, in the chaos of a family kitchen on a Tuesday evening. All of it traces back to one moment, or more accurately, thousands of moments across thousands of locations, when an ancestor of yours noticed that the thing that fell into the fire smelled better than the thing that didn't. And instead of throwing it away, they tried it. That moment of curiosity, that willingness to try the burnt thing instead of discarding it, repeated independently across dozens of populations across the prehistoric world, set off a chain of biological consequences that took hundreds of thousands of years to fully unfold. A smaller gut, a larger brain, more time, more social connection, more language, more thought, more art, more story, more everything that we consider distinctly, recognizably, irreducibly human. We didn't discover cooking. We became cooking. And here's the part that quietly astonishes me every time I think about it. You did this today. Whatever you ate, if any of it was cooked, you participated in a behavior that is older than our species, older than language, older than art, older than any belief system, any tradition, any cultural practice you could name. The most ancient human habit that still exists, unbroken, in the daily life of nearly every person alive. Every time you turn on a stove, you are doing what Homo erectus did in Wonderwerk Cave a million years ago. The technology changed, the food changed. The fire is sometimes now just electricity running through a coil. But the behavior, the fundamental act of applying heat to raw material before consuming it, is completely unbroken across a million years of human history. Not once did a single generation look at cooked food and say, actually, let's go back. Because once your brain grows large enough to appreciate what cooking did for it, you don't give that up. You build kitchens, you write cookbooks, you develop cuisines, you make it art, you make it culture, you make it the thing you do when someone you love comes home. You make it the centerpiece of every celebration, every ritual, every moment of genuine human connection you can think of. The most human thing we do started as an accident, and somewhere along the way, it made us human. So next time you're standing at a stove, or waiting for something to come out of the oven, or smelling food being prepared somewhere nearby and feeling that involuntary pull toward it, that's not just hunger. That's a million years of biology reminding you what you are and how you got here. What's the most important meal you've ever had? Let me know in the comments. Until then, see you soon.